To determine the appropriate panel breaker size for the water source heat pump, we refer to the maximum fuse size provided in the technical data. In this case, the maximum fuse size is 60 amps. Therefore, a 60 amp breaker should be used for branch circuit protection. Selecting the correct conductor size involves using the full load amps or FLA of the heat pump, which is 27.2 amps. Since we are using a dual element time delay fuse, we need to account for its maximum rating when determining the appropriate conductor size. This is achieved by multiplying the FLA by 1.75. The calculation is 27.2 amps multiplied by 1.75, which equals 47.6 amps. Based on this calculation, I'm referring to the National Electrical Code, or NEC. The appropriate conductor size is number 8 American wire gauge, or AWG. It is crucial to understand the importance of verifying the specific requirements of the local electrical code and the manufacturer's instructions before finalizing the selection of the panel breaker size and conductor size. Local codes may have additional requirements or restrictions that must be followed. The manufacturer's instructions provide specific guidance for their equipment. Deviation from these guidelines can result in unsafe conditions or void warranties. Breaker sizing and conductor sizing are essential aspects of electrical installations, directly impacting safety and operational efficiency. Firstly, understanding the role of a circuit breaker is paramount. A circuit breaker is a safety device designed to protect electrical circuits from overcurrents, which can result from short circuits, overloads, or ground faults. When an overcurrent occurs, the circuit breaker trips, interrupting the flow of electricity and preventing damage to equipment and reducing the risk of electrical fires. Secondly, conductor sizing ensures that the wires used in an electrical circuit can safely carry the intended current. Undersized conductors can overheat, leading to insulation damage, voltage drops, and potentially fires. The NEC provides tables and guidelines for determining the appropriate conductor size based on the ampacity, or current carrying capacity, of the wire. Thirdly, the full load amps, or FLA, represents the current drawn by the heat pump motor under normal operating conditions. This value is crucial for determining both the conductor size and the circuit breaker size. It is usually found on the equipment nameplate or in the manufacturer's specifications. Fourthly, the minimum circuit ampacity, or MACAR, is the minimum required ampacity of the branch circuit conductors. This value takes into account the FLA of the motor, as well as any other loads connected to the same circuit. The MCA is typically higher than the FLA to provide a safety margin and account for intermittent loads. Fifthly, the maximum overcurrent protection, or MOCP, specifies the maximum size of the overcurrent protection device, such as a circuit breaker or fuse, that is allowed to protect the circuit. This value is typically higher than the MCA to allow for motor starting inrush current, but it should not exceed the conductor's ampacity. Sixthly, dual element time delay fuses are a type of overcurrent protection device that provides both overload and short circuit protection. They are designed to withstand temporary overloads, such as motor starting currents, without tripping, while still providing fast protection against short circuits. Seventhly, the NEC provides detailed tables and guidelines for determining conductor ampacity, breaker size, and other electrical installation requirements. NEC Table 310.15b16, previously known as Table 310.16, is a commonly used table for determining the allowable ampacities of insulated conductors rated up to 600 volts. This table takes into account the conductor size, insulation type, and ambient temperature. Eighthly, when selecting a conductor, it is important to consider the insulation type, as different insulation types have different temperature ratings. Higher temperature rated insulation allows for higher ampacities. Common insulation types include THHN, THWN, and XHHW. Ninthly, ambient temperature affects the ampacity of conductors. Higher ambient temperatures reduce the conductor's ability to dissipate heat, resulting in a lower ampacity. The NEC provides correction factors for adjusting ampacity based on ambient temperature. Tenthly, voltage drop is the reduction in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. To calculate voltage drop, one needs to consider the conductor length, current, and resistance per unit length. Using larger conductors can reduce voltage drop. In the specific case of the water source heat pump, the provided data includes an MCA of 26.8 amps, a maximum fuse size of 60 amps, and a total full load amps of 27.2 amps. The question raises the issue of whether the FLA can be multiplied by 1.75 for breaker sizing since the horsepower is not provided. In general, multiplying the FLA by 1.75 is a common practice when using dual element time delay fuses for motor protection. However, it is essential to verify that this approach is permitted by the NEC and the manufacturer's instructions. If the manufacturer's instructions specify a different multiplier or a specific breaker size, that should be followed. Based on the given information, since the maximum fuse size is 60 amps, a 60 amp breaker should be used. This is because the breaker should not exceed the maximum fuse size specified by the manufacturer. For conductor sizing, we multiply the FLA of 27.2 amps by 1.75, which results in 47.6 amps. According to the NEC, a number 8 AWG conductor with a temperature rating of 75 degrees Celsius or higher is suitable for carrying 47.6 amps, assuming that the ambient temperature is within the standard range. However, it is important to consult NEC Table 310.15b16 and apply any necessary correction factors for ambient temperature and the number of current carrying conductors in the raceway. In summary, for the water source heat pump with an MCA of 26.8 amps, a maximum fuse size of 60 amps, and a total FLA of 27.2 amps, a 60 amp breaker and number 8 AWG conductors are appropriate. However, always verify these values with the local electrical code and the manufacturer's instructions to ensure compliance and safety. Proper electrical installations are essential for the safe and efficient operation of electrical equipment. Understanding the NEC guidelines, the equipment specifications, and the local code requirements is crucial for selecting the correct breaker size and conductor size. Remember to consult with a qualified electrician if you have any questions or concerns about electrical installations. They can provide expert guidance and ensure that the installation meets all applicable codes and standards. In addition to the steps outlined above, there are other considerations to keep in mind when selecting the appropriate panel breaker and conductor size for a heat pump. Firstly, consider the starting current of the heat pump motor. Motors draw a significantly higher current when they are starting than when they are running at full speed. This inrush current can be several times the FLA. The circuit breaker and conductors must be able to withstand this inrush current without tripping or overheating. Dual element time delay fuses are designed to handle motor starting currents without tripping, but it is still important to ensure that the breaker and conductors are adequately sized. Secondly, consider the voltage drop in the circuit. As mentioned earlier, voltage drop is the reduction in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause the heat pump motor to run hotter and less efficiently, and it can also damage the motor over time. To minimize voltage drop, use larger conductors or shorten the length of the circuit. Thirdly, consider the ambient temperature. The ampacity of conductors decreases as the ambient temperature increases. If the heat pump is located in a hot environment, it may be necessary to use larger conductors to compensate for the reduced ampacity. Fourthly, consider the type of wiring method used. The NEC specifies different ampacities for different wiring methods, such as conduit, cable, and open wiring. Make sure to use the correct ampacity for the wiring method being used. Fifthly, consider the number of current-carrying conductors in the raceway. If there are multiple current-carrying conductors in the same raceway, the ampacity of each conductor must be derated. The NEC provides tables for determining the derating factor based on the number of conductors in the raceway. Sixthly, consider the grounding requirement. The NEC requires that all electrical equipment be properly grounded to protect against electrical shock. Make sure to install a properly sized grounding conductor and connect it to the heat pump and the electrical panel. 7th, consider the overcurrent protection requirements for the heat pump motor. The NEC specifies different overcurrent protection requirements for different types of motors. Make sure to select the correct type and size of overcurrent protection device for the heat pump motor. 8th, consider the disconnecting means requirements. The NEC requires that all electrical equipment have a disconnecting means that can be used to disconnect the power to the equipment. The disconnecting means must be readily accessible and clearly labeled. 9th, consider the labeling requirements. The NEC requires that all electrical equipment be properly labeled with the voltage, current, and other important information. Make sure to label the heat pump and the electrical panel with the correct information. 10th, consider the inspection requirements. Most jurisdictions require that electrical installations be inspected by a qualified inspector to ensure that they meet the NEC and local code requirements. Make sure to schedule an inspection after the heat pump is installed. By following these steps and considering these additional factors, you can ensure that the heat pump is installed safely and correctly. Remember to always consult with a qualified electrician if you have any questions or concerns about electrical installations. They can provide expert guidance and ensure that the installation meets all applicable codes and standards. Furthermore, understanding the specific requirements for heat pump installations is crucial for ensuring safety and efficiency. Firstly, heat pumps often require dedicated circuits due to their high power demands. This prevents overloading other circuits and ensures that the heat pump receives the necessary power for optimal operation. Secondly, the location of the heat pump can affect the selection of wiring and overcurrent protection. If the heat pump is installed in a damp or corrosive environment, it is important to use conductors and enclosures that are rated for those conditions. Thirdly, heat pumps may have specific requirements for the type of overcurrent protection device used. Some heat pumps require the use of tie and delay fuses or circuit breakers to prevent nuisance tripping due to motor starting currents. Fourthly, heat pumps may have specific requirements for the size and type of disconnect switch used. The disconnect switch must be readily accessible and capable of interrupting the full load current of the heat pump. Fifthly, heat pumps may have specific requirements for the grounding system. The grounding system must be properly sized and installed to protect against electrical shock. Sixthly, heat pumps may have specific requirements for the control wiring. The control wiring must be properly sized and installed to ensure that the heat pump operates correctly. Seventhly, heat pumps may have specific requirements for the condensate drain. The condensate drain must be properly sized and installed to prevent water damage. Eighthly, heat pumps may have specific requirements for the air filter. The air filter must be cleaned or replaced regularly to ensure that the heat pump operates efficiently. Ninthly, heat pumps may have specific requirements for the maintenance schedule. Regular maintenance is essential to ensure that the heat pump operates reliably and efficiently. Tenthly, heat pumps may have specific requirements for the warranty. Make sure to understand the warranty terms and conditions before purchasing a heat pump. By understanding these specific requirements for heat pump installations, you can ensure that the heat pump is installed safely, correctly, and in accordance with all applicable codes and standards. Always consult with a qualified electrician for assistance with heat pump installations. They can provide expert guidance and ensure that the installation meets all requirements. In addition, it is essential to stay updated on the latest revisions and amendments to the NEC and local electrical codes. Electrical codes are constantly evolving to reflect new technologies, safety concerns, and best practices. Failure to comply with the latest code requirements can result in fines, penalties, and safety hazards. To stay updated on the latest code changes, attend continuing education courses, subscribe to industry publications, and consult with qualified electrical inspectors. Remember that electrical safety is paramount. Always take the necessary precautions to protect yourself and others from electrical hazards. Work with qualified professionals, follow all applicable codes and standards, and never take shortcuts when it comes to electrical installations.